Good afternoon, everyone. I'm Jenny Gove, and I'm a UX researcher here at Google, and I work on user experience of web experiences.
And I'm Pete, a developer advocate on the web team.
There are lots of reasons to love the web. For me, it's the scale. It can reach users all around the world on almost any device, and the only thing they need is a browser. It's easy to use and easy to share. There's nothing to install. It's an open ecosystem that anyone can use or build on. For the past few years, we've been talking a lot about progressive web apps. PWAs are enabled by a new set of capabilities that allow us to radically improve the user experience we provide to our users. We think a great experience is based on 4 things. First, the experience must load fast and feel fast. This is more than just about how fast something loads across the network, but also how long it takes us to get useful content onto the screen. The experience also needs to feel integrated. In other words, it needs to feel natural to the user's device. It needs to launch in the same way that other apps are launched on that device, and take advantage of the capabilities of the device in the same way that other apps do. For example, using the payment request API to make payments a snap. And the experience must be reliable. It should always work, because when it doesn't work, or when it loads too slowly, it breaks that user experience, and it really destroys user trust. Even here in the Bay Area, believe it or not, there are areas with poor cell coverage. And there are people here in the US that have to use dial-up to get online. And worldwide, more than 60% of cell phones are on 2G networks. So creating a reliable experience is crucial. And a PWA is an engaging experience. And that engaging experience starts at the very beginning with a delightful first-run experience for the user. It continues throughout all of your critical journeys so that they work perfectly, without friction. An engaging user experience uses the magic of the web. It's indexable, searchable, linkable, and shareable. The experience is timely and relevant, and it's precise, because it accounts for users' context and what matters to them now. In all these aspects, but especially on making your experience engaging, you should work closely with UX professionals, user researchers, and designers to identify those critical journeys for your experience. This includes basic experiences that are really imperative to get right. Things like asking for permissions only when you need it, not when the user first opens the app and there's no real need to ask for it at that point. And asking people to sign up and to sign in at the right time, when they're appropriately invested in the task that they're doing, and there's something in it for them to gain from doing so, not only something for your business to gain. Other very important flows to get right are payment experiences that we alluded to earlier. These have to be quick and easy and frictionless. Make it easy for the customers to give you money, and for them to be delighted, not frustrated by that experience. I'm going to be covering this more on Thursday at 10:30 on stage 7 in another talk called Google Pay, Best Practices for Great Payment Experiences. And, of course, removing friction in forms. We've talked a lot about performance of forms before and the user experience of them, but there are still really plenty of poor experiences on the web, we've found out. We did a recent audit, and that was conducted in Europe on 400 top sites. And we found that 42% of the sites from across 15 countries didn't show the appropriate keyboard for the input type that was needed. This causes, of course, significant friction, and that was quite a surprise to us. It was so many. It's a best practice that's been out there for a long time.
At this point, shouldn't it be called a standard practice?
Yeah, all of these should, I think. They're very sort of basic experiences, but we're finding that a lot of the time people aren't getting them right. We also found that 27% of sites didn't clearly identify which fields were optional. And that causes a number of issues for users. For example, first of all, the user might be overwhelmed just by the number of fields that they have to fill in, when that's actually not true. And second, they might get hung up on trying to complete an experience that's actually not applicable to them, ultimately causing them to give up entirely. So it's critical to make sure you're following all these best practices of web design, using the right input type, using features appropriately. We have a set of principles here we developed through conducting extensive research that can help guide you towards creating a more engaging user experience. So you can find those at that link.
We often refer to this whole idea as FIRE: fast, integrated, reliable, and engaging. And the key to building those fast and reliable experiences is service workers. Service workers are now supported in every modern browser, including Safari and Edge. Apple shipped support for service workers back in March, and with the recent update to Edge just last week, they're now supported there too. Browser vendors are also adding all kinds of new support for new capabilities that really enhance the user experience. Edge got push notifications, and they're doing some interesting stuff with the add to home screen through their store. Firefox now has support for push notifications and is working on the web authentication APIs, and Safari is also working on those new web authentication APIs.
So let's take a look at a very successful PWA that was launched by the team at Starbucks. It takes advantage of many of the new capabilities and brings a modern web experience to their customers. It makes it easy to browse the menu, customize and place an order, or pay for an order in store. All right, so I'm going to go over here, and I'm going to go to Starbucks. All right, and then I'm going to sign in, and it should sign in automatically. I'm using Pete's account here. Pete's going to buy me a coffee.
I try and be a nice guy once in a while.
OK, and here we're signed in. And then I'm going to add it to the home screen here, so I can add that. And let me shut that app. And here it's been added to the home screen, so this is my progressive web app now. I'm going to launch it from here. OK, so now I'm going to order my coffee. So it's asking me if I want to use a location, because it knows I'm going to be browsing and looking for an order. So let's see. I think I'll have a coffee, perhaps a Cafe Misto. Let's see if it's going to. There we go. Actually, maybe I'll go for an Americano. All right. So it wants me to have a grande. I think I'll make that a bit smaller. Let's pick a tall. I'm going to go for a splash of milk. All right. And I think a little bit of sugar. All right. So let's add that to my order. And I can change the location here if I want to. This is my nearest, though. I'm going to confirm the store, add that to my order. Oh, I've got two now. I've got one for you. OK. And let's take a look. So there they are, actually. And I can check out from there. So I won't leave them sitting there. We probably won't go and pick them up.
Yeah.
All right. So now, let's say that I was somewhere where I didn't have a good connection. So I'm going to put this into airplane mode. And this happened to me recently, actually. I visited London, which is where I'm from, the UK. And I was going to see a friend. And I knew that Starbucks was on the way, but I was on the tube. And I had some time on my hands. I could actually browse the menu here and see what I wanted to order on the way. So that was a pretty cool experience. And So it's able to do that, so I can make good use of my time when I want to do that. So these experiences extend even to payments. So should I be somewhere where I don't have a connection, say I'm visiting a different country where I don't have a connection, and I go into the store and I want to pay, then Starbucks has also cached my payment details so that I'm able to pay in the store right there. So that's Starbucks' progressive web app experience. And let's go back to slides. So this improved user experience has really paid off for Starbucks. One of the ways that they measure success is by the number of daily and monthly active users. And that's more than doubled from their previous experience. So it's really paying off. Users are placing more and more orders through the web app, with the number of orders growing by 12% week over week. And because Starbucks took a responsive approach and made sure that this worked nicely on desktop as well, they're seeing desktop users using the web app in order to order ahead so that the drink is ready when they get there. So let's go back to that fast, integrated, reliable, and engaging principles to see why the Starbucks app has been so successful. So your site has to be fast. You've seen this number from us before, probably many times. But if your site takes more than 3 seconds to load, you've lost more than half of your users. Your site not only has to load fast, it needs to feel like it loads fast. And the way Starbucks does this is to use placeholder content, like you can see here, until the actual content is loaded. So at first glance, it looks like things have started to load to the user. Those gray placeholders are really quickly replaced by real content. And on fast networks, or when the content has already been cached, you won't even see or be aware of those placeholders. Another aspect of that fast experience is the navigation between pages. Navigations feel fast, and they are fast. It never feels like the page does a full reload, as it can often on the web. Navigations shouldn't rely only on the network, but instead everything should be pre-cached and ready to go.
So to reduce the friction of sign-in, Starbucks uses the Credential Management API, which makes sign-in as simple as a one-tap thing. It's a pretty exciting new API, and AJ's going to be talking a lot more about it in his talk on Thursday called Sign Up and Sign In on the Web. So definitely check that one out. And as you can see, we've got the add to home screen. We didn't reset the phone properly. I'm sorry. That was my fault. I was responsible for that. But you get the add to home screen prompt there, so letting the user know that they can add this to their home screen. When the user adds your progressive web app to their home screen on Android, Chrome automatically creates an APK for you, which we sometimes refer to as a web APK. That web APK means that your app shows up not only on the home screen, but there in the launcher and in your settings, so that you can go in and see where the permissions are, you can see how much storage is being used, and so forth. Today, Chrome automatically will show that add to home screen prompt when the site is not already installed, the user's interacted with the site for about 30 seconds, and it meets the PWA criteria, which means that it's got a web app manifest, a service worker with a fetch event. Of course, the easiest way to test that is to use Lighthouse. In fact, we literally have a Lighthouse set up in the web tent, if you haven't gone over there and seen it, where you can go and run your site through it and talk with folks on the web team to understand what's going on. There's also a talk tomorrow on Lighthouse and the Chrome UX report that'll go into a lot more detail on how you can use these tools. Today, before Chrome shows the add to home screen prompt, it's going to fire a before install prompt event. And this gives you control over when that prompt appears. For example, in the Starbucks experience, they don't want that prompt to show up if I'm in the middle of ordering a drink, right? You want the user to finish what they're doing and then say, oh, hey, add this to your home screen. You don't want to distract the user. So in the default event handler, what you do is save a reference to the event and call prevent default on it. Prevent default says, hey, don't show up. And you can save that event so that in a moment, when you're ready to show it, when you're like, OK, hey, this is a useful time for this to be visible, you can call prompt on that saved event. You can also tell when a user has added your app to the home screen by listening for the app installed event. And so the app installed event will tell you that, hey, yes, they clicked, I want to install this, and Chrome or whatever browser was successfully able to add it to the user's home screen. Now, that's today. Chrome is going to automatically show you the prompt, but it's changing. All right? Starting in Chrome 68, Chrome is no longer going to show that prompt automatically. Instead, you're going to need to listen to that for that before install prompt event, then trigger the prompt by calling prompt on it on that saved event with a user gesture. All right? Now, to make the experience reliable, Starbucks used Workbox with a combination of pre-caching and runtime caching strategies. By pre-caching their content, they were able to ensure that the key resources that the app needed to run were always there. They wouldn't have to wait for the network. Then, as the user uses the app, they're able to cache additional content as they navigate around. Placing an order offline would be kind of amazing, but it's impossible, right? So instead, what they allow users to do is, as we showed earlier, is you can pay for your order. They use IndexedDB to store information about the user's previous orders, about the nearby stores that they've gone to, and their payment details, so that that can always come up and always be available.
Starbucks focused on the user experience to make their progressive web app engaging. Placing an order has to be easy, so that users can customize their drink with the many possible options available. Starbucks paid attention to the fundamental details, like the navigation stack, making sure that the back button always does the right thing. For example, navigating down several pages, the back button navigates step by step back up rather than jumping back to the home screen or some other random page. To make the experience feel more alive, the Starbucks PWA uses content-specific animations and messaging to provide feedback to the user. For example, after clicking Add to Order, it shows a toast, letting me know that it's been added to my bag. As you can see, through creating a fast, integrated, reliable, and engaging progressive web app, Starbucks have put their customers first in developing an experience that meets their users where they are, in the context that they live, they work, they play, to make it simply a convenient and delightful experience in order to order a favorite drink.
All right, so have we burned that FIRE acronym in your head yet? OK, look,
Bad.
I like bad jokes. I got a couple more set up for you, so be ready. In any event, a bunch of teams at Google have been working on building their own progressive web apps. Google Search uses a progressive web app to make it possible for users to ask questions when they're offline and then provide an answer once they've reconnected. It uses service workers, background sync, and push notifications. By using service workers, they were able to reduce the number of external JavaScript requests by nearly 50%, and they were able to reduce the number of user interactions that were delayed by loading JavaScript by 6%. So they saw a pretty good performance improvement. There's also Bulletin, which is a new way to create and share hyperlocal stories, and it's all built around a progressive web app. It's a tiny fraction of the size of a native app, and it's got 100% of the functionality. They do some really neat stuff with the media capture API so that you can take a picture or take a video and then post it up to Bulletin. And sharing is as simple as sharing a URL. And the Maps team recently shipped a progressive web app. They saw progressive web apps as a way to radically improve the experience for their users on low-end devices or in limited or flaky network conditions. Previously, many of these users were getting a so-called light experience that was designed with mobile in mind, but it didn't take advantage of a lot of the new capabilities that progressive web apps has to offer. The progressive web app doesn't have feature parity with their native app, but instead centers around 4 key user journeys. Again, see that bad pun? Yeah, I told you there were a few. Anyways, that they felt were really important. First, they wanted to make it easy for users to see their location and nearby landmarks so that they could get a sense of where they are. Second, they wanted to make it easy to find places with either search or on a map. Third, they wanted to make it easy to see what was nearby and help them discover new places. And finally, they wanted to make it easy to get directions, so that they could figure out how to get to those places that they've discovered. And users are using it even more. The new experience is seeing 20% more successful page loads compared to the previous experience. Specifically targeting low-end devices meant the team really had to put that extra effort into making sure that everything was fast. Performance was prioritized from the beginning by establishing code size, load time, and memory benchmarks that could be measured with every single commit. They used Chrome DevTools to tune memory and performance and tested on slow networks, always looking for any regressions. And of course, they needed to make sure that it worked reliably, even on those flaky networks. So they set a goal to be mindful of how much data that they were using and try and keep that in check so that for users on expensive data plans, they wouldn't consume too much of their data. So let's take a look at the Maps progressive web app. So I'll open it up here, and I've already installed it on here. You can see that, oh, I guess we should come out of airplane mode. That would be kind of helpful. One of the neat things you can see, they have that no internet. They give you a little indication of whether you're online or not. So I can see this looks like the standard Maps experience. It's maybe not quite as shiny, but I'm going to go check out and try and find a place that I've been once or twice before, sports page. It pops up really quickly, almost instantly with the information. It's got that standard page view, so I can see information about the things that I'm looking for. And if I clear this out and then go into offline mode, even though I'm offline, it remembers the places, oh, there we go. It remembers the places that I've been to before, so that if I click on sports page, that's all still there. And it's cached in an IndexedDB table so that it's always there and ready to go. So if we can switch back to the slides, great. So with the previous Maps experience, they really focused to put as much data as possible into that initial HTTP request so that they could reduce the number of requests that had to be made for the app to start. That meant inlining things like CSS and JavaScript and HTML templates, stuff that they might need for one thing but not for something else. They wanted to have everything there so that they could get started right away. With the progressive web app, they've refactored the code into really super fine-grained modules that are only served by the service worker when they're needed. So unlike the traditional experience, it only loads and runs the code that's needed. If the user doesn't need directions, it doesn't have to load or execute that code, meaning everything runs just that much snappier. Many of the users are on flaky or 2G networks, or they've got expensive data plans, and they turn their data on and off fairly frequently. And the Maps team wanted to make sure that that experience for them worked reliably, no matter what their network connection was like. To achieve that, they use service workers to cache the core app shell of their app, and so they can eliminate the network for that initial stuff. But then they started to think about how they were going to store the map tiles. Map tiles are about somewhere between 10 and 20K each, and you imagine as you pan and zoom, you can start to load a lot of them. And in fact, you can load like dozens of them by panning and zooming pretty quickly. And those map tiles change frequently. Imagine as new businesses open and close, as things change, those map tiles are constantly in flux. So storing those tiles using the Caches API was going to be a little bit complex for what they wanted to accomplish in V1. And so what they decided to do is use the browser cache. But they did it in a really neat way. As each tile is successfully loaded, they store the details of that tile in an IndexedDB table. So later, when the browser goes to get it again, the service worker regenerates the URL based on the version information and is able to go back to the browser cache, and in most cases, is able to pull that tile back from the browser cache again. For things like searches, directions, and that kind of stuff, all of that is saved in IndexedDB. So that's always there on the user's device, even if they're offline. To help eliminate some of the jankiness that is possible and reduce the amount of graphics memory that's used, they used the Layers panel in Chrome DevTools to identify elements that were off-screen and remove them from the DOM. That also shows them really useful if you go into 3D mode, the stacking context of your page. If you're trying to figure out what's going on with some of the layers and what's going on there, it's a really useful tool. It's one of my favorite ones that I've just recently started playing with, but it's been around for a while. They also decided to limit the amount of transparency and box shadows that they have. So, for example, the search box that you see up there is a full width element. In the normal experience, it's a floating element that's got the map tiles drawn behind it. So in this case, they don't have to draw the map tiles behind it or anything like that. They're able to save a bunch of memory. One of the biggest challenges that they faced in building a progressive web app was that the storage APIs are scoped to the origin. And I didn't realize this, but Maps is actually served on Google.com. It's not served on maps.google.com. So that means it shares the same storage as, obviously, Maps, but also Search, and Chrome's default new tab page. Any service that Google serves is going to share that. So they had to be really careful not to step on other folks' toes. As a developer, one of my favorite tools is the Clear Site Data button. It removes the service workers, gets you back all the saved data, and lets you start from zero. And of course, that includes the cookies. As I was digging into this to try and figure out what was going on, I kept getting signed out of mail, and I couldn't figure out why. And then I went, oh, yeah, clearing my cookies signs me out of all my mail was a bit of a pain in the butt.
Thanks. OK, so we attribute a lot of the progression of progressive web apps to mobile. And mobile has really been the key focus of the development for progressive web apps to date. But while the growth of mobile has been strong, we mustn't forget that desktop usage is, in fact, still growing, as you can see in this chart here. This graph shows that mobile phone use peaks in the morning and the evening, and tablet also has significant use in the evening time. Desktop usage is more evenly distributed throughout the day, when most people are at work and at their desks. It's mainly led by productivity apps. Many of the key apps we use every day, for example, Google Docs, messaging apps like Slack and Chat, and music streaming apps like Google Music or Spotify. Having that installed native feel can be really important to users because it gives them the confidence that the app will be fast, integrated, reliable, and engaging. To achieve this, some developers have built desktop apps using web technologies and then used a framework that embeds their application in a custom-built web browser. In fact, that's what Spotify does today. But it feels kind of redundant to ship an entire browser and your code, especially given that the user already has a browser on their machine. Not only have you significantly increased the size of your download, but you now have to keep that rendering stack up to date. You have to patch security vulnerabilities and more. So you're responsible for your app and maintaining that rendering stack in this case. There is a better way to create desktop web apps. and with a smaller footprint, and that emphasizes user experience as well. And that's to deliver a PWA for desktop. Users have high expectations for desktop apps, and progressive web apps on the desktop also need to be fast, integrated, reliable, engaging. You can say that with me now, I'm sure. That means they launched from the same place as a desktop apps are launched, so that's familiar to users, but they run also in an app window. So they look and feel like other apps on the desktop. And that's why we're working to bring progressive web apps to desktop. The demo we're going to show you today is on Chrome OS, but work is already well underway to support Windows and Mac as well. And Windows users can already install progressive web apps through the Microsoft App Store. So let's take a look more closely at the PWA experience on Chrome OS, exploring Spotify's desktop PWA. So I'm going to move to this Pixelbook now. So let's go to Spotify. All right. So now I'm going to open my web player. All right. And you'll see here that it asks me if I want to install the app. So I'm going to say yes, and this dialog comes up. I can click Install here, and if you look quickly and closely, you'll see it land on my shelf down here. So that was pretty quick, right? There it is. And I'm just going to close that out and show you how easy it is to launch it as if it was my beautiful app experience here. So, Pete, I heard about the band tomorrow night. Did you hear Justice?
I heard. I'm kind of excited.
Should we have a little listen?
Let's sure. OK.
Go for it.
All right.
Come on.
1, 2, 3, 4, 5.
I like this, but maybe you should just keep going. I know.
Oh, won't go off. there we Come on.
I just closed the window.
Shut for me.
There we
but
go.
The rest of the demo was good.
Now,
so you saw there that it was in. I can launch it again. Let's see if it'll play. You can see the install app has gone here. Because now I'm in their progressive web app, and it's using the whole of the screen. It's in the app window, and it's just a great experience that I can launch directly there from my shelf. All right, let's move back over to slides.
Cool. Getting started isn't different than what you're already doing. This is not like it's a whole new class of apps or anything like that. All of the work that you've already done for your existing progressive web apps still applies. Service workers make it fast and reliable. You can use push notifications to keep users up to date. And the Add to Home screen uses the same set of criteria as it does on mobile. The only real difference is that instead of running in a browser tab, it's running in an app window. With app windows, there are no tabs or address bar. It's just your app. And it's optimized really for the needs of apps with more flexible window organization. App windows also make it really easy to switch between windows by alt-tabbing. I want to point out a couple of things in the app window that I think are kind of interesting. As I mentioned, it takes up the full screen. You've got the standard minimize, maximize, as you'd expect. And on Chrome OS, the title bar is themed based on the manifest colors. Speaking of the web app manifest, I do want to recommend that you future-proof your apps by adding the scope property. The scope property defines the set of URLs that the browser is going to consider within your app. If you leave that set of URLs, it'll bounce you out to a browser tab. This is really important because in the future, this is going to be used for determining behavior like link capturing. Within the menu, there's also that app menu there that gives you the URL and a bunch of other sort of useful things that you want to get into.
Now, there are some unique design considerations you need to take into account for building desktop progressive web apps, things that don't necessarily always apply to progressive web apps on mobile devices. Apps on the desktop have to have access to significantly larger screen real estate. Don't just pad your content with extra margin, therefore, but use the additional space by creating new breakpoints for wider screens. Some applications really benefit from that wider view. When thinking about your breakpoints, think about how users will use your app and how they might resize it. In a weather app, a large window might show me a 7-day forecast. Then, as the window gets smaller, instead of shrinking everything down, I might get a 5-day forecast. And as it continues to get smaller, content might shuffle around. I can still see that same content. It's just optimized for a smaller display. For some apps, a mini mode might be really helpful. This weather app shows me only the current conditions. And a music player might show me just the current songs and the button needed to change the song. You can take this idea of responsive design to the next level to support convertibles like the Pixelbook or the Surface. When switched to tablet mode, these devices make the active window full screen, and depending on how the user holds the device, maybe either landscape or portrait. So you need to focus on getting responsive design right, and that's what matters here, whether the user has resized the window or the device has done so because it's switched to tablet mode. Responsive design is critical to a successful desktop progressive web app experience. The app window on desktop opens so many new possibilities, so work with your designer and take a responsive approach that adds new breakpoints for larger screens, supports landscape or portrait views, works when full screen or not, and works nicely with those virtual keyboards. And what's next? Well, as mentioned, we're already working on support for Windows and Mac, and for all the platforms, we're looking on adding support for keyboard shortcuts so that you can provide your own functionality, badging for the launch icon so that you can let users know about important events that you don't want to display a full notification for, and link capturing, opening the installed PWA when the user clicks on a link that needs to be handled by the app. So keep an eye out for announcements on the Chromium blog that you see here for updates, and start playing with it today.
All right, so we have about a minute and a half left to cover the last section. So I'm going to go really fast. I won't actually go that fast. I'll cover the key stuff. We'll get this out in another video. But for many users, having an app available in the store is really critical to your business. And we know that there are a lot of cases where this makes sense, and that it makes sense to integrate your web content into your native app. Today, you can do this using either a web view or custom tabs, and each has its own benefits and drawbacks. I won't go through these right now. I'm going to sort of skip through this so that we can get into a little of the fun details. We've heard from you that one of the things you want is to be able to show web content in your native app, but have a lot more control over it. And Trusted Web Activities allows you to integrate that experience. They're powered by custom tabs, which means that your content is rendered by the user's up-to-date browser. This isn't a mechanism simply to just wrap your website and throw it up onto the Play Store. A simple mistake can cause some kind of drastic problems. Trusted Web Activities are designed to make it possible for you to use the investment you've made in your web app inside of your Android native app. There are a couple of requirements. They must be done as first-party content, so the content has to be yours. You need to add an intent filter in your manifest, and you need to pass the same progressive web app criteria as we've talked about earlier. And of course, you need to follow the standard Play Store guidelines. So there's 4 things that you need to do. Well, essentially 2, but we'll call them sort of 4. Set up a set of digital asset links, and that allows you to prove that your content belongs to you on the web, and then create the activity. The code is here. We will get this up. In fact, I'll show you. I'll just take you to the link where all of the details already are. Can I go back one slide, please? Sorry. All right. If you go to g.co, Trusted Web Activities, all of the notes for this, including all of the code to get started on this, is right up there.
OK, so let's conclude this talk so you can all get to the party tonight. So in bringing this all together, you've seen today how Starbucks' progressive web app works, how the team at Starbucks have taken care of those fundamentals, as well as the delighters to bring a more convenient and experience and great ease of use to their consumers. We've seen how Google is building progressive web apps as well, with search and maps and bulletin, and how progressive web apps can improve desktop experiences through careful design and use of App Window. And finally, you've heard about how you can integrate your PWA into your native app. All these experiences focus on being fast, integrated, reliable, engaging. And in this, they're transforming the web on mobile and on desktop.
So if you remember 3 things. 1, go check your progressive web app and listen for that before install prompt event, call show on it. Go try desktop progressive web apps and add a scope. And if you've got an existing Android app, go take a look at trusted web activities. Thanks, everybody. Please fill out the feedback form. Thank you.
Enjoy the party.